To effectively protect your home and access controls from lightning strikes, several measures can be implemented. Firstly, proper grounding is essential. Ensure all sections, including the power pole, water pipes, and existing ground rods, are correctly grounded. Install a dedicated lightning ground rod near the power pole. Connect this ground rod to the earth ground using a 6 American wire gauge copper wire. Secondly, surge protection is crucial. Install a whole house surge protector at the electrical panel. This device will divert lightning-induced surges. Supplement this with point-of-view surge protectors for appliances and electronics. These provide an additional layer of protection at the point of use. Thirdly, consider installing a lightning rod, also known as an air terminal, on top of the power pole. This will attract lightning and direct it safely to the ground rod. Fourthly, implement copper bonding. Connect all metal structures, such as the power pole, water pipes, and any metal elements of the house, with copper bonding tape. This creates a continuous electrical pathway, ensuring that lightning follows the intended path to the ground. Fifthly, establish a lightning protection zone. Install additional ground rod space around the perimeter of the area, creating a zone of protection around the house and access controls. The zone should extend at least 10 feet beyond the outer edges of the structures. Sixthly, trenching can provide a direct path for surges. Trench a cable underground between the power pole and the house. This provides a direct path for lightning surges to reach the ground rod, minimizing potential damage. Seventhly, install surge diversion devices at the entrance gates. These devices redirect lightning surges away from sensitive controls and equipment, protecting them from damage. Keep trees and shrubs trimmed away from the power pole and house. This reduces the risk of lightning striking these objects and potentially affecting your electrical system. Avoid installing metal objects or antennas near the power pole. These can attract lightning and increase the risk of a strike. Consider installing a lightning detection system. This provides early warning of approaching thunderstorms, allowing you to take proactive measures. It's crucial to consult with a qualified electrician for professional advice in installation. They can assess your specific situation and recommend the most appropriate measures. Furthermore, understanding the role of grounding is fundamental. Grounding provides a low-resistance path for electrical current to flow safely to the earth. This is especially important during a lightning strike, as it provides a path for the massive electrical surge to dissipate without causing damage. The National Electrical Code, NEC, provides detailed guidelines for grounding electrical systems. Proper grounding involves connecting all non-current carrying metal parts of the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The size of the grounding conductor must be appropriate for the size of the electrical system. In addition to grounding, bonding is also essential. Bonding involves connecting all metal parts of the electrical system together to create a continuous electrical path. This ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The NEC also provides guidelines for bonding electrical systems. Proper bonding involves using bonding jumpers to connect metal enclosures, metal conduits, and other metal parts of the electrical system. The size of the bonding jumper must be appropriate for the size of the electrical system. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, as well as other events such as power outages and equipment failures. SPD work by diverting the surge current away from the protected equipment. There are several different types of SPD available, including whole house surge protectors, point-of-view surge protectors, and surge protection strips. Whole house surge protectors are installed at the electrical panel and provide protection for the entire electrical system. Point-of-view surge protectors are installed at individual outlets and provide protection for specific appliances or electronic devices. Surge protection strips are portable devices that can be used to protect multiple devices from a single outlet. When selecting SPD, it's important to consider the surge current rating. The surge current rating is the maximum amount of current that the SPD can safely divert. The higher the surge current rating, the more protection the SPD will provide. It's also important to consider the voltage protection rating, or volts protection rating, volts PR, which indicates the level of voltage the SPD will clamp down to during a surge. A lower volts PR indicates better protection. Lightning rods, also known as air terminals, are designed to intercept lightning strikes and provide a safe path for the current to flow to the ground. Lightning rods are typically installed on the highest point of a building or structure. When lightning strikes a lightning rod, the current flows through a grounding conductor to a grounding electrode, such as a ground rod. The grounding electrode dissipates the current into the earth. Lightning rods are typically made of copper or aluminum. The size of the lightning rod and the grounding conductor must be appropriate for the size of the building or structure. The installation of lightning rods should be performed by a qualified professional. In addition to the measures described above, there are several other steps that can be taken to protect your home from lightning strikes. These include keeping trees and shrubs trimmed away from the house, avoiding the use of electrical appliances during thunderstorms, and unplugging electronic devices when they are not in use. It's also important to have your electrical system inspected regularly by a qualified electrician. A qualified electrician can identify potential hazards and make recommendations for improving the safety of your electrical system. Regarding the grounding electrode system, it's important to understand that a single ground rod may not always be sufficient, especially in areas with high soil resistivity. In such cases, multiple ground rods may be required, spaced at least twice their length apart. For example, if you are using 8-foot ground rods, they should be spaced at least 16 feet apart. The NEC specifies that if a single ground rod does not achieve a resistance to ground of 25 ohms or less, a second ground rod must be installed. Furthermore, consider using a ground-enhancing compound to improve the conductivity of the soil around the ground rods. This can help to lower the resistance to ground and improve the effectiveness of the grounding system. The type of soil in your area can significantly impact the effectiveness of your grounding system. Sandy soil, for example, has a higher resistivity than clay soil. If you have sandy soil, you may need to take additional measures to improve the conductivity of the soil around your ground rods. These measures may include using ground-enhancing compounds, installing additional ground rods, or using a ground ring. A ground ring is a continuous conductor that is buried around the perimeter of a building or structure. It provides a lower impedance path for ground fault current to flow back to the source. Ground rings are typically used in large buildings or structures where a single ground rod would not be sufficient. When installing a ground ring, it's important to ensure that it is buried deep enough to be below the frost line. This will prevent the ground ring from being damaged by frost heave. Also, ensure that the ground ring is properly bonded to the building's grounding electrode system. The bonding connection should be made with a conductor that is sized appropriately for the size of the ground ring. In addition to protecting your home from lightning strikes, it's also important to protect your sensitive electronic equipment from power surges. Power surges can damage or destroy electronic equipment, even if they are not caused by lightning strikes. To protect your electronic equipment from power surges, use surge protectors. Surge protectors are designed to divert excess voltage away from electronic equipment. There are several different types of surge protectors available, including surge strips, wall-mounted surge protectors, and whole-house surge protectors. Surge strips are portable devices that can be used to protect multiple electronic devices from a single outlet. Wall-mounted surge protectors are installed in place of standard electrical outlets and provide surge protection for the devices that are plugged into them. Whole-house surge protectors are installed at the electrical panel and provide surge protection for the entire electrical system. When selecting surge protectors, it's important to consider the surge protection rating. The surge protection rating is the maximum amount of energy that the surge protector can absorb. The higher the surge protection rating, the more protection the surge protector will provide. It's also important to consider the clamping voltage. The clamping voltage is the voltage at which the surge protector will start to divert excess voltage away from electronic equipment. A lower clamping voltage indicates better protection. Moreover, consider installing a backup power system to keep your essential equipment running during a power outage. A backup power system can provide power to your lights, refrigerator, and other essential equipment. There are several different types of backup power systems available, including generators, uninterruptible power supplies, or UPSs, and battery backup systems. Generators are typically powered by gasoline or propane and can provide power to your entire home. UPS are battery-powered devices that provide short-term power to electronic equipment during a power outage. Battery backup systems are similar to UPS, but they can provide power for a longer period of time. When selecting a backup power system, it's important to consider the power requirements of your essential equipment. You will need to select a backup power system that can provide enough power to run all of your essential equipment. It's also important to consider the runtime of the backup power system. The runtime is the amount of time that the backup power system can provide power during a power outage. You will need to select a backup power system that has a runtime that is long enough to meet your needs. It is imperative to hire a licensed and experienced electrician to perform any electrical work on your home. Electrical work can be dangerous, and it's important to ensure that it is done safely and correctly. A licensed and experienced electrician will have the knowledge and skills to install and maintain your electrical system properly. They will also be familiar with the NEC and other applicable codes and standards. When hiring an electrician, it's important to get several bids from different contractors. This will allow you to compare prices and services. It's also important to check the electrician's references and make sure that they are licensed and insured. Remember to obtain all necessary permits before starting any electrical work. Permits are required for most types of electrical work, and it's important to obtain them before starting any work. This will ensure that the work is done in accordance with the NEC and other applicable codes and standards. By implementing these lightning protection measures, you can significantly reduce the risk of damage to your home and access controls from lightning strikes. Remember to consult with a qualified electrician for professional advice and installation to ensure that the measures are implemented correctly and effectively.